Here's an x and y axis. We've talked already about how to find the slope. So there's the x-axis, there's the y-axis. What I'm going to do here is draw a line, just any line like this. If you look at this line, up to this point we've been able to find the slope. So if you know 2 points, let's say you know a point right here and you know a point right here. Okay, you can find the slope of that pretty easy. Alright? Let's make sure everything's on the board. Okay. So you can find the rise, find the run, and all that kind of stuff. Alright? But what if I did this? What if I drew another line? I just copied and pasted it, okay? And let's drop it. I can grab it. There we go. Drop it down here. Now, is this the same exact line as this one? No, it's not, because I moved it down, right? They're two different lines. Now, they do have something in common. What do they have in common? They have the same slope, okay? But they are two different lines. Would you agree? This line is way down here. This line is up here a little bit further. So if I wanted to describe, or to, that's the best word to use, okay, to describe these two lines, you use two things to describe the two lines. Okay, one thing is the slope, like we've already talked about. But another thing, now they both slant the same, don't they? Like if I got on this and I slid down this hill, it's the same steepness, it's the same slope as this one right here. Okay, it's got the same steepness. But it's a little different. This one's a little higher up than this one, isn't it? So they're two different lines, but they have the same slope. Now, so let's just do this. Let's talk about how to describe these two lines. One way would be looking at the line and talking about the slope. So you can figure out the slope of this thing. Let's just make something up. Like if I went from this point to this point, I don't know, let's say we went up 4 over 5. Okay, so the slope of this, if I went up 4 and over 5, the slope would be 4/5. Okay, I'm just guessing, just to throw some numbers in there. So if I went up 4, went over 5, that would be the slope.
Mr. Hammer.
So the slope is 4/5, let's say. But this is different. What is different about this line compared to this line? Just in any old words, what do you think? Justin, what do you think? Justin, what do you think? One's what? Yeah, one's lower. This one's lower than this one, or this one's what? Higher than this one, right? So what we do is this, is we look to see where it goes through the y-axis. So this point right here hits the y-axis at that particular point. Okay? I'm just making up points here. Let's just say it goes through 2. So this thing right here has a slope of 4/5. It crosses the y-axis at +2. We call that the y-intercept. The intercept means it's where it crosses, and it crosses the y-axis. That's why we use the word y, because here's the y-axis. This line crosses the y-axis right at this point right here. So that's the y-intercept. This point down here, or this line, I'm sorry, down here, it's got the same slope like we said, but it's got a different what? Y-intercept. So again, I'm just making these numbers up. We'll say it crosses at -3. So this y-intercept would be -3. This y-intercept would be +2. They're two different lines. They have the same slope, but they have different y-intercepts. That makes them two different lines. So let's say let's do this top one right here. So this line right here, we'll say has a y-intercept of +2. So if you're going to describe a line, you can use two things to describe this line. One of them is the slope, like we've talked about. The other is the y-intercept. So if you take a look at these two lines right here, this one has a slope of 4/5 and a y-intercept of 2. This one has a slope of 4/5 but a different y-intercept. It's got a y-intercept of -3. So they're two completely different lines. Instead of writing it like this is kind of an awkward way to write it to describe this line. So we have another way to describe the line, and that's through an equation. And we call these things equations of a line, okay? Or just an equation of a line. Equation of a line. And what an equation of a line does, it describes something about the line so that you know like how to graph it, or you know what's going on with the line. On this line right here, what do we know about this line? We know two things. We know the slope and we know the y-intercept. So this equation of a line is going to have those two things in it. It's going to have the slope in the equation, and it's going to have the y-intercept in the equation. Alright, so you've seen this before. You've probably had this in Algebra 1. Y equals mx plus b. Anybody familiar with that? Should be. Did that in Algebra 1. You might have even done it a little bit in pre-algebra if you had a pre-algebra class. We're doing it this year. You're going to do it next year in Algebra 2 as well. Okay, so you'll never get away from this. This stuff is really, really important, and you'll see it quite a bit. It's y equals mx plus b. Let's let's look to see what these things mean. I got two things up here. I got slope. What letter do we use to describe slope, though? M. All right. Remember we talked about that. We thought it probably came from like a Latin word that means something about mountains or mountainous. Okay. The M doesn't actually stand for the word mountain, but you could kind of think of it that way. The y-intercept, there's a letter that's used to describe the y-intercept. If you look at this, they actually use the letter B to describe the y-intercept. And, you know, people ask all the time, why do they use B? That's kind of weird, random letter that they use to describe the y-intercept. So the reason they use the B to describe the y-intercept is because there's another intercept as well. What intercept do you think we would call this? Call this the x-intercept, right? Because it crosses which axis? The x-axis, okay? It crosses the x-axis, so I would call that the x-axis. Now, we're not going to use the x-intercept in our equations in here. Okay, there are other equations that we're not going to talk about today that actually do talk about the x-intercept. But sometimes when they talk about the x-intercept, they actually use the letter A for the x-intercept. So what do you think? What letter do you think they use for the y-intercept? They use B. So they use A and B. A is the x-intercept, B is the y-intercept. So that's why they use the letter B for the y-intercept. Does that make sense? All right, because sometimes you think, where'd they get B from? Why? You know, does it stand for anything? Not really. It's just the A is the x-intercept because it's first, right? And then B is the y-intercept because it's second. That's basically it. So I got two things that I know. So what I'm going to do is I'm going to take those two numbers and throw them in for the slope and the y-intercept. Look at the x and y, though. The x and y, when we write in our equation of a line, the x and y just stay x and y. We don't actually write a number in for that, okay? The x and the y just stay. This stays x, and this stays y. This is a thing that we're going to put a number into. This b right here is something we're going to put a number into. So let's work this out. Y equals, what is the slope of this line? 4/5, right. And then what do I say about the x? We just write it in there, right? We just put the x. And what's the y-intercept on this? It's +2, right. So that right there describes this line right there, that top line. So just by writing that equation, I can look at it and I can tell you, just by looking at that equation, what the y-intercept is and what the slope is. And if all I knew was this, if that's the only thing that I knew, I could graph it as well, couldn't I? All right, because I know where the y-intercept is, so I put a dot at the y-intercept. The slope is 4/5, so I rise 4 and I run 5, all right, and then that'll tell me the slope of it. So you could actually graph it by knowing that equation. So the equation is very, very important to us because we want to describe that line. We want to be able to graph that line. What would the equation of this line down here on the bottom be? Be y equals what? 4/5. All right, it's got the same slope, doesn't it? You always put the x there. Now what's the y-intercept? It's -3, right. So it's plus -3, or what's the easy way to write it? Just -3. So that would be the equation of that bottom line right there. Make sense? So let's do this. Let's actually, let's take these two, let's make another x and y axis. I'll just drop this down a little bit. And here's a simple little example that they might give you. Let's change colors here. All right, they'll say, graph a line that has a slope of, let's make up a different slope, -2/3, and let's say goes through the point, whoever's clicking the pen, please needs to stop. So the slope is -2/3 and has a point of, I don't know, let's say 0.5. Okay, so it goes through this slope and it goes through the point 0.5. Now I picked 0.5 for a reason, because 0.5 is on what axis? It's on the y-axis, isn't it? 1, 2, 3, 4, 5. So we'll put a dot right there at 0.5. So that's the y-intercept, isn't it? So 0.5 is the y-intercept because it's where it crosses the y-axis. They could have just said the y-intercept was equal to 5. That's another way they could have said it, couldn't they? All right, so they could tell you a couple different ways what the y-intercept is. All right, and you want to graph this thing. So first thing that I do is I put a point wherever the y-intercept is. Put a dot right there. Now I can find the slope. All right, this is very similar to what we've been doing, isn't it? Yep, it's just rise over run. Good. So it's -2 over +3. Or you could have written it what? 2 over -3. Isn't that the same thing? All right, and if you wanted to, we can try them both. Watch. Let's go -2 over +3 first. So we go -2, 1, 2. Then we go +3. 1, 2, 3. Right there. Connect them, right? Or we could have done what? We could have started at this point and gone what? Could have gone up 2, right? Up 2 and to the left 3. But look what happens. Lies on the same line, doesn't it? You see it? So it doesn't matter if I go down 2 to the right 3 or up 2 and to the left 3. It's still going to lie on that same line right there. Right? And what do? Do I leave the dots like this? No. Okay. Even, do you remember me saying on that, was it the quiz, I think, or worksheet? Maybe it was on a worksheet. I said, don't just leave the dots. Okay? Put a line through it. And guess what happened when people turned in the worksheet the very next day after I said that? I still had people putting just dots and no line through it, okay? So put the line through it. You're graphing a line. You're not just graphing a series of points. Okay, you're graphing an entire line. So make sure that you put the line there. It's very important that you do that. If you don't do that on a quiz or a test, I'm going to mark it wrong. If all you do is put a point here and a point here, and that's it, no line through it, it's wrong. You understand? All right, so that's pretty easy if they give you that. All right, let's take a look at this one. This is right from the book, and you're going to get a worksheet tomorrow. I'm not going to be here tomorrow, so I'm going to give you a worksheet. It's going to be a front and a back, so it's quite a bit of work to do. Okay, there's quite a bit of problems on the front and the back. So you really need to make sure that you use your time wisely tomorrow in class and work on this stuff. All right, so here's one of the types of questions. Like the one we just did, is there's a whole section like that. They'll give you a slope, they'll give you a y-intercept, and you have to graph the line. Okay, here's another one. They'll give you a slope and they'll just give you some other point that's not the y-intercept. So they'll say, okay, here's a slope, which is 2, and here's a point, which is 311. Right? And what you need to do is you need to write an equation of the line. Again, what is an equation of a line? It's y what? Equals mx plus b. All right? That should be pretty familiar to you. By the way, while I'm thinking about it, since we have a slope and an intercept, they actually give it a little fancier name. It's called the slope-intercept form. And you'll need to know that word because they're going to say that on the instructions. They're going to say, write the equation in slope-intercept form. And you're going to need to know what they're talking about. So it's called the slope-intercept form. So y equals mx plus b is slope-intercept form. All right? So here's the question. Write the equation in slope, and this is on page, I'm looking at page 200, and I'm looking at problem number 19 if you have your book open, okay? But here's what it says if you don't have your book. It says write the equation in actually let's try this one anyway in slope-intercept form. They actually, I'm going to show you another form, okay? This is slope-intercept. I'm going to show you a second one. And that's what they're actually asking on number 19, and I just didn't read it. But let's try this anyway in slope-intercept form. Okay, so here's a slope, here's a point. I want to put it into this form right here, y equals mx plus b. All right? You don't really need to graph it, to tell you the truth. Let's do this. Let's just start putting numbers in here. Now, I said this x and y just stay x and y. But what the x and y actually do, they represent any point on our line. Okay, it doesn't just represent the y-intercept or the x-intercept or anything else. This x and y represents any point on our line. It's really important to understand. So, do I have a point on the line? Yeah, 311. That's a point, isn't it? So, guess what this is going to be? That's going to be the x, and guess what this is going to be? That's going to be the y. So, look what I have right here. I've got my equation. Let's write it out one more time without the box all around it. Okay, here's my equation. Look what I have. I got a slope, I have an x, and I have a y. What do you think I could solve for now? I could solve for b and find the y-intercept, because that's not the y-intercept, is it? So if I graph this thing, I wouldn't really know where the y-intercept was. In fact, let's just, you don't have to graph these, but let's just do it this first time just so we kind of get an idea. So the point is 311. 1, 2, 3, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just to get it to fit on there. All right, so there it is right there. And then the slope is what? 2. So I rise 2, run 1. Probably be about like that. Agreed? And then it'll look something like that. Now that wasn't very accurate, was it? So if I look at this, I don't want to, I'm not guaranteed that that's actually my point because I was a little sloppy right in the graph. Even if you use graph paper, sometimes it might go in between the y-intercepts and you can't tell exactly where it hits. So you want to do it mathematically, all right? But it's going to be somewhere around there, don't you think? So let's go back to this and put some stuff in here. Let's go blue. All All right, so what can we put in this little formula right here? Do we know a y? Yeah, it's 11, isn't it? So I put the y in there. Do I know an m, the slope? Sure I do. It's 2, isn't it? So equals 2. Times what? Times 3, and then plus b. Everybody see that? So now, look at this. Now I can solve for b, can't I? So let's do that. That's 11 equals 6 plus b. Subtract a 6 from both sides, and b equals what? 5. All right, now I was off a little bit, wasn't I? 1, 2, 3, 4, 5. It should have gone through here. But look, I went up and over. You see, I was really quick, really sloppy with the graph. That's why you don't want to trust your graph. Use it as a guide, but don't completely trust the graph. But I can look right here and say the y-intercept is 5. Now, what am I trying to do, though? I'm trying to write, the question says this. It says, write an equation of a line. Write the equation of a line. So is my answer the graph? No. The question says, write an equation of the line. Well, what is my equation? Y equals mx plus b, right? But now I know a couple things, don't I? So now I can just write y equals m. What's my m? It's 2, right? They told that to me. I didn't have to figure that out. They told that to me. So y equals 2, and then what do I write after that? Well, not times 3, because I'm just writing x. When I write my final equation, I just write this y and this x. What's the y-intercept now? It's 5. It's positive 5, so I put a plus 5, and that right there is the equation of that line. Does that make sense? So if they give you a slope and they give you a point, what do? You put it into this. Understand that the point is an x and a y, isn't it? All right, so you put the 3 in for the x and the 11 in for the y. They told you the slope, so you put that in for the m. You know 3 of those 4 things. So you plug them all in, you work it out, you solve for b. It's not so hard, is it? And then you find what b is, and now you just rewrite it all nice and pretty, okay? Y equals 2x plus 5. Let's do another one. This time they actually told you the slope, didn't they? All right. Well, I'll keep that for just a few seconds because I got to move on. Here's another one. So if you're writing when I was writing, you should have had all that written down. Here, let's try another one. Trying to find one that comes out kind of nice. Let's do this one. This time, this is actually a little easier version of this. Now look, they don't give you a slope this time, do they? But they give you 2 points. So they don't give you a slope and a point. They give you 2 points. But what could we find given 2 points? We could find the slope. Again, this problem says what? I'm not going to write it down, but what does the problem say? Write the equation of the line. Right, write the equation of the line. So this is what I always do. When they say write the equation of a line, I always write this down. Okay? Because what am I trying to find here? I'm trying to find the slope, and I'm also trying to find what else? The y-intercept. So I'm only finding 2 things, the slope and the y-intercept. What do you think I can find first? Well, actually, there is. You could find, in this particular problem, the y-intercept's kind of staring right at you. Which one is the y-intercept? It's 5, isn't it? Because that point is 0, 5. Do you see that? So it's not always going to do that, though. They're not always going to give you a point of 0 whatever, okay? But on this particular one, absolutely. You can look at this and say, hey, the y-intercept's 5. Let's just pretend, though. Let's just pretend we didn't know that was y-intercept, okay? Maybe we weren't thinking about it real clear. All right, so let's just pretend we didn't know that. So let's find the slope first. We've done this, haven't we? Right? These 2 points right here, we know how to find the slope between 2 points, so let's do that. We just had a whole lesson on that, didn't we? So to find the slope, what do? Subtract what goes on top? Y's go on top, not the x's, okay? Nope, you said it the other way around. So let's subtract the y's. So it's 5 minus 3 over what? 0 minus 3. And that gives us 2 over negative 3, or negative 2/3. It doesn't really matter where the negative is. It could be on the top or the bottom, okay? So that's my slope. So watch this. Now, on this particular problem, it's really, really nice to know that this is your y-intercept, all right? But let's do this. Now we know the m, don't we? So that's going to go right there, in for that. what do the X and Y stand for? It stands for a point on the line. Do I know a point on my line? Yeah, I know this point and I know this point. This is what's kind of interesting about this. Watch. It doesn't matter which point we choose, because on the other problem we just finished doing, they only gave us 1 point. We only had one choice for X and Y, didn't we? But on this one we have 2 choices. I could either use this point or I could use this point. It doesn't make any difference. Which one would you rather use? 3, 3? Okay, let's use the 3, 3. Doesn't matter, okay? I'm not going to go through both of them to show you, but you could use either one, and you'll get the same exact equation of a line. You'll get the same answer. So let's put some stuff in here. So y, if I use this point right here, what am I going to put in for y? 3, right. And what is my m? It's negative 2 over 3, isn't it? Times what? X, which is 3, right. Since I used that point, I'll put that over 1. Plus what? B. Everybody got that? So let's do the math. 3 equals. Look how nice and easy this came out. This 3 and this 3 canceled out, and I got negative 2 plus b. Add what? 2 to both sides, and what's b? Just like we said it was supposed to be, right? Now, you didn't really have to go through all this with this particular problem, because you could have just looked at 0, 5 and said, that's my y-intercept. Does that make sense why that's the y-intercept? I described it before. So if you look at it, what are my 2 points? 0, 5. 1, 2, 3, 4, 5. Right there. It's my other point. 3, 3, right? 1, 2, 3, 1, 2, 3. It's right there. Okay? And connect the dots. So that's your line. You didn't really have to graph it, okay? But look, I could just look at this, and I know it went through y-axis at 5, didn't I? Because of that point right there. That point told me that it went through y-axis at positive 5. They don't always give you that point, though. I picked one that was a little easier, okay, just to start us off with. But you saw how we could get the y-intercept even if we didn't realize that was the y-intercept. All right. So what slope does this have? It's got a negative 2/3 slope. Is it slanting the way we think it should slant? Absolutely. That's a negative slope, okay? And it does have a y-intercept at 0, 5. And so we're good to go. So let's write our final answer, though. I've got the slope right here. I've got the y-intercept. Now I got to put it all together into my equation of the line. So let's write it nice and pretty now. It's going to be y equals what? Negative 2/3 x and then plus 5. That right there is your answer. Okay, that blue thing that I just circled, that is your answer because they ask for the equation of the line. All right, let's do another one. This time, the numbers are not quite as easy. So it's negative 12, negative 9, and I'm sorry, negative 6. It's negative 12, negative 6, and it's 8, 9. And what do we have to find? We have to write the what? Equation of a line. That's what we're trying to find. And what is the equation of a line? It's y equals mx plus b. That's what we're trying to put it into. All right? So we need to find the slope, and we need to find the y-intercept. Is either one of these points right here the y-intercept? No, it's not. Okay? It's not the y-intercept, no. So, but I can find what first? The slope. All right? So remember, we're going to take this, and we're actually going to find the slope. So let's find the slope of this line. So the slope is, subtract the y's, put them on top, subtract the x's, and put them on the bottom. So that's negative 15 over negative 20. That reduces to positive, right? So that's what? 5 goes into that 3 times and 4 times, right? So positive 3/4. So that's my slope. Let's just write it like this. M equals 3/4. So that's what's going to go in right there. And now I got to find what? The y-intercept. How do I find the y-intercept? Well, I pick either one of these numbers. It doesn't matter which one, or any of these points, and I'm going to put it in for the x and the y. Which point would you rather use? Negative 12, negative 6, or 8 and 9? Yeah, I definitely would use 8 and 9. So that's my x and that's my y. Now, you could have used this point, and it would still have worked. Okay? I promise. Let's put them in here. So what we're doing is we're filling in everything that we know for this equation. So what do I know for y? I know it's 9. So it's going to be 9 equals m. What's my m? Just found it. It's 3/4. So it's 3/4 times x. What's x? It's 8. Good. Plus b. Because I don't know b. That's what I'm trying to find. Now I just do a little bit of math. Watch. It's easy math, isn't it? Watch. 4 goes into 4 once, into 8 twice. That's what? 6 plus b. So what's b? B is 3. And I'm basically done all the work. There's my slope. There's my y-intercept. Right? But how do I put it all together, though? Y equals 3/4 x plus 3. And that's it. That's my answer. It's not so bad, is it? So again, what did we do? We took the 2 points, found the slope, didn't we? All right? Plugged everything into this equation of a line. Pick one of these points. It doesn't matter. You could have picked this one or this one. It didn't make any difference. You'd still get the same exact answer, which is pretty interesting, I think, that you pick 2 different points and you get the same exact answer. So I picked this x and y. I put it in for x and y, solve for b. I've got my slope, I've got my y-intercept, and I'm done. Okay? There's another equation I need to show you. So the first one was the slope-intercept form. This next one is called the point-slope form. So write this down. Everybody should be writing all this stuff down that I'm writing. You should be writing it down. I guess, yes. So this is called the point-slope form. The point-slope form looks like this. Should be writing this down. You should be writing this down right now as I'm writing it. So y minus y1 equals m times x minus x1. Looks a little tough, but I want you to understand this x1 and y1, that's the point that they're talking about. Okay? And of course the m is the what? That's the slope. Alright? So in the point slope form, they give you a point. So this x1 and y1 is the point, and the slope is the m. Okay? So they could give you something like this. They could. Here's the problem. They'll give you a slope, and they'll give you a point. Now, we've already learned how to do this in slope-intercept form. Point-slope form is actually easier. Watch. I'll show you. I promise you. It's y minus y1. So look at the -4 and the 8. What does that represent on this formula right here? That's right. It's the x1 and the y1. Okay? So look, all I'm going to do is just chuck the stuff in here, and I'm basically done. It's really simple. So it's y minus y1. So it's y minus what? 8. Okay, equals m. What's the m? 4. And then it's going to be x minus, what's the x1? It's -4, but it's minus a -4. What's minus a -4? It's +4. So when we write it as a plus. Don't keep them 2 minuses. And then that's it. You're done with that. If they ask to put it in point slope form, okay? If they say put it in point slope form, everybody hearing me? If they say put it in this form, you write your answer like this and you just leave it just like that. That's all you do. Okay? Now, they may ask you to do this. They may say put it in slope-intercept form. So you could start off this way and then just solve for y. Let's do that. Let's see what this would be in slope-intercept form. So what would I do here? I'd probably do this first. I'd probably distribute that 4, wouldn't you? Yeah, you're right. It's 4x plus 16. Now what would you do? Now I'd add the 8, and then let's see what we get. We get y equals 4x plus, what's that, 24? And look at that. Look what I just did right there. I took this slope and this point. I turned it into slope-intercept form by using the point-slope form. You see it? All right? It all depends. Is somebody... Okay. You got to make sure that you read the instructions, because some problems will say this: write the answer in slope-intercept form. Okay, so that would be slope-intercept form. And then some problems say write the answer in what? In point-slope form. All right, so your answer should look something like this. So there's 2 different forms. Let me just do one more thing real quick. Sorry, but time's running short. I want you to look at this really quick. What if you had a horizontal and a vertical line? So there's my x and y axis, okay? And let's say you had a horizontal line. A horizontal line, let's write this down. A horizontal line is just y equals wherever it hits the y-axis. There's no x or anything in it. It's just y equals a number. So let's say that's 1 and that's 2. What would the equation of this horizontal line be then? It's just y equals 2, and that's it. There's no x's involved or anything else. Okay, it's just y equals 2, and that's it. Now, you could also have what other kind of line? A vertical line. So let's say you had a vertical line like this. Okay? Now, this goes through the y-axis, so it's y equals 2. This goes through what? The x-axis. Let's say it goes through negative 2. So what's the formula for this? It's just x equals negative 2. So that would be a vertical line. Okay? That's it. You got a worksheet tomorrow. You're going to be working all class period on that. And that'll be due on Monday.